All right, so my talk is security with ClickHouse, building for the long term. I don't know, I just wrote something on the plane this morning. My name's Evan Johnson. My Twitter handle, or X, or whatever you want to call it, is up here. And I'm from a company called RunReveal. I'm the co-founder and CEO. Who am I? I'm not a data person, so I'm appreciative of getting to speak at like a data meetup. I have a security background. I was the first security engineer at Cloudflare. I was leading product security there for like 7.5 years. And now I'm like the CEO of like a security data company. So that's quite an adjustment. So it's been a learning curve. So maybe some of this stuff, feel free to like nerd snipe me if you have recommendations or ideas about what we're doing with data wrong. But it's been pretty fun so far. So what is RunReveal? Does anybody know what a SIM is? Many people in this room have already told me that they do. We've got some takers. It has its own Gartner Magic Quadrant. It's basically just like security and data. Basically, security teams store all their data in these enormous databases, and it's called SIM. And every security person also hates the SIM that they have. So if you go meet a CISO or something, like if they're a Splunk customer, you know that A, they have a lot of money, and B, they hate their life. And so that's what we're trying to fix. So security people have a lot of logs, and we're using ClickHouse to help them manage those. There's also, it's not just SIM. Oh, I reuse SIM. There's a bunch of other acronyms for the same thing, which is just putting security logs in a database. There's MDR, managed detection and response, so you've lost all hope and you completely outsource the whole practice. There's XDR, which is SIM, but the marketing people like zhuzhed it up a little bit. There's CDR, which is cloud detection and response. And then there's ITDR. I think that's identity something detection and response. But I thought it was like IT, and I learned this one last week. But it's really funny because security people only want a few things with their data. They want to keep it for longer than a year. And so that's a big one. That's where the Splunk costs really like go out of control. That's for forensic purposes. They want to like run queries and search for different threats, but last and most importantly, they want to not deal with any of their data problems. So they just like, if you talk to any security person, they'll say like, I just want it to work. I don't want to think about like why this query is slow. I ran a query, I want a result, and I don't want to think about it. So if you're a CISO and you get to a new company, CISOs, if you follow along with where your CISO goes that you worked with in a past life and what they're doing now, you'll see that they move around a lot and they go to new companies pretty frequently because they usually get blamed for a lot of stuff and get pushed out. And so it's frequent that they're buying one of these products up here. When you land at a company as a CISO, you normally say, okay, we need to do some type of detection with all of our data. And I put ClickHouse up here. If you say ClickHouse to a CISO today, most of them have no idea what you're talking about. But they usually look for like one of these four things right now: Splunk, Snowflake, BigQuery, Elastic, and ClickHouse hopefully soon. But there's a bunch of other products in the same space. There's Exabeam and Logarithm, Microsoft Sentinel, QRadar, Alien Vault, to name a few. Google has their own Google Chronicle. And so the space is chaotic. This like whole practice of just like store logs and search them for threats, really chaotic. So Elastic, Snowflake, BigQuery, really easy to start with. Usually security people find that their ops team has already stored a bunch of logs in an Elasticsearch cluster somewhere. Snowflake, they already have a contract with Snowflake in place, and BigQuery just like costs nothing to get started. And so they're like, let me start with these. Enterprise ready. Splunk and Elastic are usually the most enterprise ready products that you can buy for like, I need a solution for my security logs. Snowflake might be getting there. There's some other companies that are trying to help companies do that. And I don't really know, but we tend to think that the best option is ClickHouse. And so when the security people say that they don't want to think about their data problems, they're really saying that they want speed, reliability, good UX, cost efficiency, tech support, clean data, all the above. And that's really hard. So we try to bridge that gap with Go and ClickHouse. and that's our product. So I'll give you a deep dive on all the technical components of how RunReveal works. The first most important component is RRQ, which is like RunReveal Q. And it's just a big Go binary that we put on a bunch of machines. All of our EC2 instances, we don't have Kubernetes, we don't have containers, we just run Go binaries with systemd the way the good Lord intended. And the RRQ process is just a big process that is implementing this RunReveal Kala abstraction. You'll see here, it might be hard to see, source, destination, handler. So there's data sources, there's data destinations, and then there's a custom handler that we've written that handles all of like business logic of processing every single log. So it looks kind of like this. In practice, we've got a bunch of sources, a relatively small number of destinations, and then one big handler. That one big handler is doing a bunch of things. So first is event validation. Sometimes people just send us weird data that we don't understand what it is. Sometimes we have to we always normalize data. So every single log, I'll show you in a moment, we transform into a unified schema, and we can do transforms ourselves. Enrichment, so like most security logs have like an IP field, and we append a bunch of data to it, like what country was that IP associated with at that time? What are the latitude and longitude estimated of that IP? And then last, we do some streaming detections, and then the types of destinations that we have. One, the most important one, sorry, ClickHouse, is dev null. If you just want to drop the log entirely, it's not important. There's also blob storage, really low costs for like bulk data collection. And then there's ClickHouse for the stuff you want to search and use later that you think is important. This is the type of like destinations, this is the type of detections that we run in the stream. There's this format called Sigma, and it's like for detection engineers to represent their detections as YAML. That's we've implemented a Go package that does that. So this is the way that we kind of add functionality to the stream with Go packages one at a time in those handlers. So that's kind of the RRQ process. What we do in ClickHouse, I think, is probably a common pattern. I'm curious to know more though. When we receive a log, we have this kind of Go struct. You can't see all the fields here, and also some of it's hidden in other structs, but it gives you an idea of what the normalized log looks like. We take every single individual log from every source and we put it in this format. So things like your source name, your source ID, your organization ID, that kind of stuff. And then notice, importantly, we keep the raw log around. So we pull out the important fields like event name, IP, actor. Those are in this normalized thing here. But then importantly, we store the raw log, the raw JSON that we received. This is what our table looks like. We've got one big table called the logs table. What else would we call it? And the primary key on it is pretty simple. It's changed a little bit. I don't think this is the updated one, but it's mostly just based on the received at time. And then obviously like workspace ID to do segmentation by customers and all of that stuff. But received at time is the most important one. So every log that we receive from this RRQ process, we write to this table. From there, what we do is we have to present the data, and there's a few other problems that come from that. So people, when they are looking at their logs, they want to look at the log the way that they're used to looking at the log. Like if you've read a CloudTrail log, you don't want to read it in my log format. You want to look at it like a CloudTrail log looks. So we have a bunch of views, a mix of views and materialized views for handling that process. The materialized views are really nice because you can add additional indexes and stuff. And the views are really nice because we can drop them at will and fix them and break them and whatever. They're super lightweight. Additionally, what's nice is people care about how much they're going to be billed, how much what's happening in the product. They have a bunch of other data things that they're curious about. And so we use a mix of materialized views for calculating how much data they've even logged. And then additionally when things break, we log it to other tables, or when detections fire and we see bad things, we log it to the detections table. Oh, when things break, we log it to the source errors table. I misspoke. And then when we spot some bad stuff, we log it to the detections table. So we've got the logs table, and then it trickles down to a bunch of views, and then we've got some other tables that are helpful for other kinds of questions our customers might have. I know what you're thinking. We must be really excited about the JSON data type. This is what our views look like, and luckily enough, LLMs are pretty good once you've got a few of these to like just do the rest. And so actually the way I write these is I normally do like the first 2 lines myself, and then I just like press tab and Copilot takes over, and boom, we're good. But this is what like our Octalogs table actually looks like, and this is how we do it. So it's a mix of pulling things out of the normalized log fields that we already have in the logs table, and then what's left over in the raw log field. This is when customers say, I just stored, I don't know, we had a customer who logged like way too much data, and it was actually our fault. And to count that though, we have this materialized view where we're keeping track every minute of how much data each source is receiving, and storing it in this RunReveal source volumes table using this materialized view. And it's pretty clever, but it seems to work. This is what the product looks like when you're like looking at the detections table and pulling that kind of stuff out. Not super interesting, but you'll see here, if you want to see what's broken, this might be very hard to see because it's hard to see for me even. But if you zoom, I cannot enhance further. But if you zoom in, you can see that this is like an error column, and it's just text about like, oh, your Octalogs broke or whatever. Somebody revoked the API key, and yeah. So that's kind of what that looks like. And then we also can use those tables for all sorts of like little fancy widgets. When we see something in the like source, when we don't see data in the RunReveal source volumes table, and we see errors in the source errors table, then we say that your source is unhealthy, your Notion source is unhealthy, and we can show you how many errors. That's all driven through ClickHouse. I thought that this was a good example. We have a customer, Harvey AI, who just spoke at a ClickHouse meetup last week, who they were talking about like they're doing really cool threat detection stuff with all of their network logs, sifting through tons of IP addresses going from their systems. And it was really cool because it's a ton of data, B, a ton of rows and a ton of IP addresses, and then C, they're able to just like search it. We made them a special materialized view because they want to do a bunch of threat hunting and a bunch of searches of these tables, and they want it to just feel like magically fast. And so we made them a special materialized view, and just works. And this is the type of like analytics that they're doing. They're looking for like big spikes in external, like outbound traffic, new ports that are being called out to, that kind of stuff. We have another important process that's called RSchedule. I think this is spelled right, but yeah, RunReveal scheduling. And there's a bunch of like scheduling tasks that we've had to bolt on functionality for. So like when you set up a Okta source, for example, this is my favorite source to tell people to use because Okta has a ton of customers and they all have a lot of money. And I say, you should use the Okta source. It takes 1 minute to get set up. And they just plug in an API key here. It's the reason I tell them to use it is because it's the easiest one to set up. And we add a bunch of detections, and then we tell them if it breaks. I go over that in every demo call I do with a CISO. And the source health check and the detections actually work the same way in our schedule. And the way that they work is they're queries that we schedule with Postgres. So we've got a database that's very important for like kind of both the data plane and the control plane, where we just have like a cron schedule. We have scaled out our schedule the same way we do RQ, where we just run it on a bunch of EC2 instances, and then we lock these rows individually with like Postgres locks when a R schedule picks up its next task. And so this has worked really, really well. That process just like queries ClickHouse a bunch and runs whatever query is here. And we've added support so that our customers can pass like custom parameters and all that kind of stuff to these queries, and it seems to work really well. But you'll notice the naming convention here. Health checks we set up automatically for the customers, and those are underscore health underscore check underscore whatever. So those we just hide in the UI. But yeah, takeaways, I couldn't think of a third one, but I feel like ClickHouse has been really good to build around. The user experience as a developer has been really good, and also our customers. One of the things that we do with customers is sometimes we say, we don't want to hold your data hostage. If you want to sign up with ClickHouse Cloud, like we'll just stream, we have a table, destination configs, and we'll just write data to your own ClickHouse cluster. And they've really liked that, and that's worked really, really well. And they've also liked they've figured out the user experience of like using ClickHouse, which I think can sometimes have some rough edges, but also it's super powerful, and I think that they get that. And then also, I think that there's a lot of use cases and opportunities to do this kind of thing that we're doing in probably a lot of other spaces. I worked at a company called Segment for a while too, and they were like trying to do this kind of thing, but with user data and like creepy watching what people are doing on every website that they go to data, and then like figuring out how can we get them to buy things and spend money. But I feel like this same architecture would have worked really well in like a lot of other applications, not just security data, could be any kind of data. So any other takeaways that I missed? There's another blank here, but that's my whole talk.